Today, we want to look at the Memento design pattern, which is one of the design patterns you guys are expected to understand. So we're going to look at just discuss what this design pattern is, when it's used, and how to provide an implementation of using Memento design pattern. So what I've got here is an extract from your tutorial later, which has a lot of other design patterns. I've just taken an extract from where it talks about Memento. I'm just going to read through this quickly, and then we can get into the details of this design pattern. So it does mention things here, but a Memento is an object that stores a snapshot of the internal state of another object. So that's very important to remember, because everything in this design pattern surrounds this Memento class when we get to the actual classes. But in general, a Memento is an object that stores a snapshot of another object, and in this state can only be read by the original object. So this is a very important summary that we'll get back to, but it's important to note that the only object that can read from this Memento is the original object. So this is important for our discussion. All right, so this allows an object state to be restored at some later point, allowing for an undo or rollback operation. What we have in this section is not the Memento pattern, but rather an implementation of the serializer pattern. Okay, so we will discuss this section about the serializer pattern. I think there's a whole section that explains this specific example, but what we have in this section is not the Memento pattern, but rather an implementation of the serializer pattern. Okay, so the game of four do not include the serializer pattern in the set of patterns, although other authors do. Serializer is used to stream objects into other data structures writing, and is also responsible for restoring objects from such a data structure reading. It is commonly used to write and restore the state of an object to a file or database, allowing for storage and retrieval. Okay, so this is from your tutorial later, so you can go back and look at what they were referring to here. Now, here they mention the serializer pattern, which is used to serialize or write the state of an object, usually to files and databases or to anything external, or read the state of that object. So this is what we've done whenever you're writing XML, when you're creating XML files from classes, you are serializing. That is actually the serializer pattern. Or when you are creating objects from XML files, this is something that you could have done in assignments, but it shouldn't be something new. But when we talk about XML, we talk about writing to a file. That's an example of serializing. So the relation now between Memento and serializer is all around state, right? There is an object state that is being kept somewhere with the ability to also read it back from that destination or wherever it's being written to. So we have an intersection here, which is an object state. So we won't dwell much on the serializer pattern, but it's one of those design patterns we also look at. It's the simplest of all, because it's all about reading and writing, and that's all. Right. A comment here about Q-object reader and Q-object writer. These follow the idea of a serializer well, in that neither knows anything about the structure of the objects passed to it, and serializes the object as it finds it. The stock control project, So these are some of the things you can go and look at if you've got access to these things. Now, here's what we need to also understand. The Memento pattern is a behavioral pattern. This design pattern is applicable when the state of an object needs to be saved so that its state can be restored later without violating the encapsulation of the class. Now, we have to talk about this point here. So what we are looking at right now, where we are saying we don't want to violate the encapsulation of the class, has also to do with this point that we underlined here, which says, and this state can only be read by the original object. It's part of the same requirement. the data members of the class, which determine the state of its object, may not all be accessible via setters and getters outside the class. Hence, the class itself has to be involved in saving and restoring the state of its objects. Okay, data members of the class, which determine the state of its objects, may not all be accessible via getters and setters outside the class. Hence, the class itself has to be involved in saving and restoring the state of its objects. Right, so that's just a quick summary of what the Memento pattern is. The main points to note is that the state of the object can only be read by the original object. So reading through this, we've got two objects, a memento, which is responsible for keeping the state of another object. Now that state in the memento can only be read by the original object, which is the object where we have copied from. So a memento is a copy. We're creating a copy of another object, right? And we are saying that copy that we have created must only be read by the original object that we copied from. No one else should ever have access to this state. And by doing that, we are avoiding violating the encapsulation requirements of the class, right? Which means once a copy has been created for a class, the original class should not be worried about its state being modified somewhere else, which means its encapsulation requirements, or its privacy rather, is maintained even though its data has been given to another object to store that state, which means the accessibility of that state, which we have copied into another object, should still be maintained and managed by the original class, which means that class must always be involved in saving and restoring the state, its state, all right, or the state of its object. So there are two classes to take note of here. We've got number one, the original object, and number two, we've got the memento object. Now, the memento object is where we are saying this one stores a copy, right? A copy, which is we are referring to as the internal state of its original object. And we are saying the original object must be involved. In order to maintain privacy, or in other words, in order to maintain its encapsulation requirements. In other words, must be the only one that can read its copy. I've squeezed things here, but these are the two main points that I want you to take away from everything that we have read. We've got the original object and we've got the memento. The original object is worried about encapsulation or privacy. It wants to make sure that once I've given my state to this memento here, can I still feel confident that nobody's going to tamper with it? Those are the encapsulation requirements. Therefore, this process of copying data to and from the memento must be handled by the original object. Or in other words, it has to be involved in order for the original object to feel confident that that state has not been violated in any way. It's like you've got a secret and you give it to somebody to keep that secret for you. How do you ensure that it's never going to go anywhere? Now, this won't work in real life, would it? Okay, all right. So moving forward now, with this idea of an original object that wants its state to be stored by another object, which is in this case the memento, this leads us to the memento design pattern and the classes involved. Now, here we end up with three classes. So we've got one class which is referred to as the originator, one that is referred to as the memento, and one that's referred to as the caretaker. So whenever you apply the memento design pattern, these are the three classes involved. So the presumption is that you already have an originator. You've got data sitting in a class, or you've got a class that has got an internal state that you want to preserve. Therefore, in most cases, you are simply introducing two more classes, which are then these two classes. So these you introduce. So that's mostly what happens whenever you're dealing with memento design pattern. Like in the In an assignment, you're given a class, you're given a solution, and then to that existing solution, you then want to add a backup facility or a restore facility. Just give me 1 second, sorry. All right, thank you. So yeah, I was saying that these are the 3 classes involved whenever you are trying to apply the Memento design pattern. You've got an original object or the originator, and then you've got the Memento class, which we talked about earlier, and then we'll also discuss the caretaker. All right. So in terms of the originator, the Memento design pattern is all about the state, because that is what you're trying to preserve. Now, the state of an object is just usually your private member variables in a class. That's your state. Whatever is under private, usually because we do store data members of a class under private. So usually that is what makes up the internal state of a class, right? So whatever that is, which is under private, or whatever that is which a class can keep, any values that your class can keep in any instance, that is what you want to preserve, right? For instance, you can have a list in your class under private, right? Or your class could be a list. Now, when you want to bake up that list, you are trying to make sure that at any point in time, you want to make a copy of that list as it is at that given point in time, right? So you make a snapshot. So that state then goes into another object. So these are usually just the same. This is always same thing, right? So whatever state you have in your class that you want to back up, you are simply introducing another class that can keep that state. So whatever this is, you want to put that under private in this class called Memento. And the Memento class is nothing but a class that is get and set functions. So it allows you to get this state, and it allows you to set this state. That's all it is. It's one of the simplest classes you can ever create, because all you're doing is you're looking at the original class that you want to back up, looking at the state that you want to, preserve, then make a copy of this in another class with get and set functions. So you're simply taking the current value of this and storing it in an instance of another class. So you can store a lot of these. So which means if you want to keep on backing up these values as they are changing, you simply make instances of this class. So I'll come back there. Just wanted to paint a picture here of what's going on with these 3 classes. We'll come back to this one. The originator, right? The state of the object of this class are being saved and restored. So again, this is the one you're trying to preserve. To save the state of an object, it creates a snapshot of its state by creating a memento via the create memento function. To restore the state of the object, it uses a memento via the set memento function. Right, so what's going on here? We are saying this is the class that should make a copy of this state. To make a copy of this state, we create a class that simply represents this with a get and a set, right? Now, to make an instance of this class, we are going to introduce 2 functions here. One function allows us to take this and make an instance of this class using this function, set state. In other words, you're making a variable of type memento. You take the value of this, you give it to this class by using the state function, the set state function, and therefore you've got an instance. If you want to restore, you simply get an instance of this class. You call the get state function, which will give you this value as it was at that point in time whenever it was created. So you take this value, you simply reassign it to this value. That's the process. That's what's going on here. So in other words, if we come back to what's going on here, we are simply saying that your create memento function is taking this state and making an instance of a memento using the set state function. So it takes the current value of this state and makes an instance of a memento, set state. So at this point in time, whatever value we have here becomes the same value that we have here. So we can keep this somewhere else. This can then change, but remember, this won't change. So we can add 4 more items to our list. But if originally we had 2 items, this will still have those 2 items because this is not being touched by anyone. It's just a copy of what this was. So this is the function responsible for that. No, sorry, my bad. This is the create memento function. This is the one doing this. This one here is taking the state of an object and then creating a memento instance. To restore, we receive an instance of this class, as you can see here, right? So we are getting a memento, right? Which is this instance here. As you can see, this function receives a memento instance. Then it takes this memento and it goes to your state and it assigns it the value using the get state function. So all this function does is it receives an instance of the memento, the one that you created earlier, which is a value as it was whenever it was created. And then you take that memento, you call the get state function, and you simply assign it to this state. So that's like the create and restore operation right there. The next thing is just to do this in code. So this is not complicated. It's just simple logic. Creating a backup and restoring from a backup. Your backup is a set backup function and a get backup function, or set state, get state. That's all you do. All right. Memento. This is the class that stores the state of an originator. This class is simply responsible for keeping the value inside your originator, which is this. Caretaker keeps the memento. Now, this class is responsible for keeping these, because the next question was, where do you keep this? You make an instance of a memento. Where does it go? So this class is nothing else but a list of mementos. So in other words, we can simply say this here is a list of mementos, depending on whether or not you want to store one or many. But it's the class responsible for keeping them, right? Now, the role of the caretaker is to only store the memento, and it is not allowed to access the state of the originator saved in the memento. One way of achieving this is by making the get state, set state, even the construct of memento private, so that the caretaker cannot access the state of the originator. However, the originator needs to be able to access the constructor, get state, and set state of memento. One way of achieving this is then by making originator a friend of memento. So remember we said that the originator is worried about encapsulation or privacy, and we said it has to be involved, right? So how does the originator ensure that whatever it gives to this memento is not touched by anything else? We make everything in memento private. By making everything in memento private, we're ensuring that nobody else can call any of these functions. We can give this class to another class, to another function. It doesn't matter. Nobody can access these 2 functions. That way, the originator is guaranteed that once the state is in this instance, nobody else can ever access the state in this class. Therefore, the encapsulation requirements or the privacy of the originator is preserved, which is what we discussed earlier here. But if we then make everything private, the question becomes, how then does the originator access these functions? Because functions or anything private within a class can only be accessed within that class. So the only way to allow a class to access anything private within that class is to make it a friend of a class. In other words, we make originator a friend of memento to ensure that only the originator can access memento functions. Memento functions. And this then allows us to achieve encapsulation. So your originator is not worried about the state or its state being modified outside of this class. Because remember, the whole reason of making stuff private within a class is to make sure that nobody else knows about that state outside of the current class. But in this case, what do? We are taking that state and giving it to another class. So to ensure that that privacy contract is honored is by simply making everything private. So this is the encapsulation requirements of requirement of the Memento design pattern. Caretaker requests a snapshot of an originator using the create Memento function. The originator in turn creates a snapshot of its state by passing its state to Memento and thus creating a Memento, which is then passed to the caretaker. If the state of the originator is to be restored, then the caretaker can invoke the set Memento function to restore the state of the originator. So if your caretaker wants to be responsible for managing the backing up and restoring of your originator, it's going to play with these two functions. It will call this function to get this function to get a Memento. It keeps it somewhere, and it will call this function to restore from a Memento. So in other words, you don't always have to introduce a caretaker class, because sometimes your client can also act in some way as the caretaker. So I'll do this with reservations, because sometimes you may use a client to do this based on how many backups you're creating. But if it's more than one backup, I would then recommend having another class, because you don't want a list of items within your client. You'd rather shift that to a separate class, which is responsible for managing backups. Or in other words, if you then create a class that is responsible for the backing up and restoring of these backups, you can then move that logic to the caretaker. So in other words, backup, restore logic can be put here. So this we will then know when to back up, when to restore, and this class can also just call relevant functions to then achieve the whole backup facility. And this is important because sometimes they do ask you to explain Memento just in terms of how it works, what classes are involved, who is doing what. So it's quite important to understand the Memento class just from the theory perspective without touching or writing any code. This, ladies and gentlemen, is the Memento design pattern. All right. So our next objective is to illustrate the kind of code we are going to be writing for this design pattern. And to do that, I'm not going to create a solution here. I'm just going to write code here just to illustrate what classes are involved, what kind of code are you writing. And I won't use any complicated state here like a list. I'm just going to use an integer or a queue-string, right? Just that you understand how the Memento design pattern functions without complicating, the whole backup, restore, or set create Memento logic. So let's just say we've got a class that is a queue-string. How is everything else structured? Okay. So let's begin by just having a class, right? Now, I also need you guys to understand that in this design pattern, even though we've got the originator, Memento, and caretaker, it doesn't mean that within your solution, you've got to call this class originator and this one Memento and this one caretaker. No. These classes can be given more friendly functions and names based on your context. So here, we are calling them originator, Memento, caretaker, because we are explaining their responsibilities and what they are in this design pattern. But it's not always when you're going to see the word Memento. And actually, more often than not, you won't even see the word Memento. You just see classes with names. And then you have to figure out which one is the originator, which one is the Memento, which one is the caretaker. All right? So it's very clear for you to understand that these are more of responsibilities than names you have to use when designing your solutions or applications. But in most cases, you will have this already. So what you may then have to do in terms of updating an existing class or solution to then provide a backup facility is introduce this, introduce that, introduce these two functions here. So that is what you may have to do. If you've got an existing solution that is with a class that you want to, back up and restore, or whatever you want to do, or rollback facility, whatever you are trying to do, these are usually the things you would need to introduce a Memento class, a caretaker, and then you would add these two functions to your original class. So, and just to make sure that we are all following, I'm simply saying, let's say you've got an existing solution. What you're simply going to do is introduce these two classes and introduce these two functions. These are usually the changes you would make inside your existing solution if you want to apply a Memento design pattern, or you want to introduce a backup or restore facility. That's two functions here, new class, sometimes new class, or you can use an existing class for this, which is usually your client or your main window. Your main window can also act as this, depending on how many backups you want to create. But for now, let's just keep this logic, introduce, introduce, introduce. Okay. Now, I'm going to be coding here. I want to write, I'm not going to create a solution. I just want to do it here and illustrate all the code involved. And then we can maybe create a solution that just runs with exactly the same code so that we can see how the backup and restore actually works. But I don't think we'll get to that today. So let's say we've got a class, string class, right? And this class has nothing but string class, there's our constructor, and under private, we've got a Q string here. I'm gonna call this state, right? It's just normal, it's a simple class. And within this class, we've got maybe a get and a set function. So we've got a Q string, get state, and void set state, which takes a Q string state. So that's a very simple class. I am not going to implement these two or these three functions. It's just a basic, simple class that you have, right? Representing an existing class. Now, given that we've got this string class, I'm going to do a solution, but let's just focus on this. How then do we introduce Memento, right? So the first thing to identify is which class are you trying, which class has this state you're trying to preserve? Because that becomes your originator. So in this case, this is the one I want to back up. So this becomes my originator. The first step I need to do is to create a Memento class. Now, a Memento class should keep this for me. Whatever is under private, because remember, this here is your state. Whatever is under private, that's your state. And we are saying this class here then becomes your originator. So the next thing is to introduce a Memento class. What I'll then do is I'll go, I've identified that this is what I need to back up. That's my originator. So the next thing I'm going to do is to introduce another class, which is then my Memento. So I'll go class Memento. So in this class, now I'm going to do this once. Everything is going to be private. The constructor, any get functions, any set functions, including the actual state. So what I'm going to do here, let's just say this here is called name, right? Just so that it's clear, because I don't want to use this state all over the place and then you start thinking this is the same as that. That's your class. String class is a name, it is under private. So let's say these functions are actually called get name and set name. So that's your class, just a normal class. Now, in this Memento class, I'm going to keep the word state, because your Memento class doesn't care what it is. It's just going to say, that's my state. Whatever this is, you create here. So your starting point is sort of like identifying this, and then under private, just copying this section and replicating it in this class here. Then obviously introducing a get function, a set function, and a constructor. But everything being done under private. Now this creates a complication. How then is this class going to use these functions in this class? That's where we say you make it a friend. So what you then do in this class is you just go, you add a statement, friend, class, string class. So whatever this originator is, you make it a friend of this class. So by including this statement, this ensures that your class, string class, is now a friend of this class. And just to be consistent, that should be a capital, not a variable. And there we go, just to make it clear. Okay, perfect. So you're then going to introduce this statement, which then ensures that this class here is a friend of this class. Therefore, inside this class, you can actually make an instance, call a get function, a set function within this class. That's basically how you want to do your Memento. Now, these functions are all simple. I'm not going to implement these functions. This one simply returns this. This one sets this from this, right? For instance, if I was going to implement my set state function here, it's just going to be, state equals S. There's nothing complicated going on. That's how you'd implement this function, just a normal function. Get state returns this. So it's nothing complicated here. So I don't think for Memento design pattern, it's the implementation that's complicated. I think it's just the logic and understanding what classes are involved. Now, within your originator, we then need to introduce two functions. One that's going to allow us to create a Memento, and one that's going to allow us to restore from a Memento. Now, remember, I don't have to call this class Memento. So I'm going to rename it and just say, well, this is a backup, right? But in the design pattern, this is actually my Memento class. Right? So when I say this is a backup class. Now, inside your originator, you need two functions, right? You need a function that's going to create a backup, a function that returns your backup. So I can say here, create backup, and that's it. So I can use this function to create a backup. So this function returns an instance of your Memento class or your backup. The second function that I need in here is a function that can restore from a backup. So I can go void restore, and this gets a backup B. Now, these two functions are exactly these two functions, one that creates a Memento and one that receives a Memento and restores from it. These are these two functions. Now, to implement, what's going on here? Oh, okay, let's just do this. To implement these two functions here, right? We are going to, it's the implementation details for these two functions are very simple. So let's do our create backup function, right? This function is going to do this here, okay. So these are the only two functions I'm going to try and implement. So the create backup function is going to return a backup, string class, create backup, backup. There is my function. This function is going to make an instance of a backup, B, and I'm going to go b.setState and give it my name, and then return my backup. Now, this logic can be simplified. I just did it in 3 steps here, but it can definitely be simplified. What I'm simply doing here is making an instance of this class using the constructor, calling the set state function, which is this function, giving it my state, which is my name, and then returning an instance of this class. So this instance that I'm returning here is going to have whatever value I have here. This name can continue and can go on and change, but this one won't change because I've already put it inside an instance of backup, so it will stay. Now, if I want to restore from a backup, which is this function, what I'm simply going to do is says void string class restore takes a backup B, and within this function I'm going to get a string from B, or actually just one line of code. I can just go name equals B dot get state. That's how I restore. So the name then goes back to whatever state this was given. That way I have restored. So that's basically how you would implement these two functions, your create and your restore. So as you can see, all the code involved in this design pattern is actually very simple and straightforward. There's nothing complicated here. The only thing that matters is how are you going to copy the state of this into a copy of this. This can be a list, it can be a queue string. That is all you've got to figure out. But eventually, this is all you are doing. Your original class introduced these two functions, implement them. You introduce this class, which is your Memento or backup, and you do your encapsulation requirements. Everything is private. And your state here, whatever this is, you've got here. So this keeps a copy of this here. It allows you to get it and set it whichever way you want to do it. You can do it via the constructor if you want. So you don't really have to have a set state function. You just do it via a constructor if I want. So it's your option. So that's basically how you wire things up with the Memento design pattern. Now let's go to a caretaker. All right. Let's say you've got a class here that is responsible for managing your backups, right? So what I'm going to do here is what's explained here, where your caretaker is requesting a snapshot of an originator using the create Memento function. And then to restore, it's going to request, and that's creating a Memento, which is then passed to the caretaker. If the state of the originator has to be restored, then the caretaker can invoke the set Memento function to restore the state of the originator. In other words, the process for creating a backup and restoring involves these simple steps, right? Number one, you want to request a backup or Memento from the originator. In other words, what you're doing here is you're calling the get Memento function, whatever you called that function. Number two, give backup or Memento to the caretaker. Done. That's how you create a backup. Now, to restore, you are going to get Memento from the caretaker. And then step number 4, I'm then going to pass Memento to originator. In other words, I'm going to call the what was it? Create Memento, set Memento function. Set Memento, or whatever you called this function. In this function, we call the get state, which in turn calls the get state function. So that's basically what's happening in this whole process. So in terms of code, let's say we had a caretaker, and in this case, I'm going to make it very simple. I'm doing this in the caretaker. So I've got my string class C. Then I can go C dot set name equals some name, right? Like that. What I can then do is I can say backup B equals C dot, what was the function? Here it was create backup. That's what we called it. So here I can then just go C dot create backup. That's step number one. I'm requesting for the memento from the originator, right? Then C, we can change the name of C to something else. So C can change the name to something else. Whatever happens, happens. Now, if I want to restore, I'm simply going to get my backup and give it back to the originator. So what I would do in this case is I'll simply go C dot restore B. Yeah. So I'm giving my memento to my restore function. So that's how I would, number one, create a backup. And that's how I would restore. Now, because this backup is being stored here, I'll then say this here is my caretaker class. Wherever I'm doing this, I'm actually in the caretaker. But there are some complicated scenarios where you might want to introduce a caretaker class. For instance, I can actually create a class called backups, right? So in this case, I can say, let me create a class called backups. So I can do this here. So let's have a class backups like that. And what I can actually do is I can say backups is just go public. Let's do it here. Public. Then I can go queue list backup like that. So my class here is simply a list of backups. And therefore, this can become my caretaker. So that's what I have here. Right, so if I do it like this, let's just put a line here. If I do it like this, that means I can actually change my logic here. For example, I've got my backup that I've created here. I can assign this backup to a caretaker, right? So I can actually here create backups, right, like that. So I want to store many of them. And what I can then do is I can take this backup that I've created here and store it in my backups. I can go backups, append B. And I can do this as many times as I want, right? Do this many times. Whatever trigger causes that. So I can keep on creating more backups, putting them in my backups. Now, names can change. Now, to restore to the first original name, I just have to get a backup from my backups. I can just go backups, backups.at0, for example. This would restore to the original one. Or you can have some control Z functionality where you keep on restoring to from the last created backup by just implementing some sort of logic where you get the latest created one, and you can keep on going backwards until you get to 0. So I don't want to go into those details, but basically I'm just trying to show you that all the logic involved here is just around creating these mementos, keeping them somewhere if you want to keep many of them, and just, calling your create backup, restore function, which receives a backup. And you can just play around with this code depending on the actual implementation details. But at the end of the day, this is what the Memento design pattern is all about. All right. Okay, so today I want actually create a solution, but what I want to do maybe in the next is a continuation of this example, is to actually have something that we create main window with our restore, create backup functions and buttons, and we can illustrate this actually working. But for today, I will stop here. Let's have some question. There you go.
I know that it's probably obvious, but how do we were talking about one attribute now, or one property that we were sending to the Memento class. How would you handle, instead of just a name, a whole name, date, type, all of that? Would you just append multiple values to a single backup, or do you generate it into an object and then send the object?
Very good question. So in this example, we just illustrated everything using one item. But what if we had two? What if we had a name here and a date and something else, right? So what you do is whatever this is, this becomes. If you've got 4 items here, put 4 items here. If you've got 2 items here, put 2 items here. So if, let's say this was the case, I was going to then, let's move this upwards a little bit. I was going to put 2 items here. Maybe state 2, whatever you want to call it. You can use any names here. And I'll introduce 2 more functions. So there will be set state, get state, and another get state for this one. So, and remember, you can actually use get name, get date, set date here, if you've got more than one. What's important is that when you then restore, you're going to then go set state twice. So for instance, if I had set state 1, set state 2 for this date, here I'll just do it twice. I'll go b.set state 1, b.set, maybe set date, if that was the function, and I'll give it my date here. And to restore, we'll have 2 functions to get everything that you are keeping here. So you can actually keep more than 1 attributes, which can be 2, 3, 4. So whatever you have here, we are simply creating a class that allows you to get these 2 items and set these 2 items. And again, you can still use a constructor for that. So I can have a class that only has get functions, and I use the constructor to set everything that I want to set here. And I just use those, I'll just use those functions here. So that's how you'd approach it. So if we had 3 items, we would put these 3 here. You can have 3 functions to get each of those items, and you would use either your constructor or your set functions here to set those 3 items, and you would still access those 3 functions here to retrieve the values of those 3 attributes that you would have stored here to reassign those values back to your originals.
And then this is like saving to cache, basically, because if the program ends, all these classes dump and then you don't have it anyway. Whereas if you use a serializer, you would apply the serializer at the caretaker level, right?
So when we start doing revision classes, one of the questions you're going to encounter is what's the difference between Memento and serializer? And the answer is what you've just explained. Memento does not allow its state to be given to anything else outside. So Memento actually stores in memory, if we say it in other words. Whereas if you then use serializer with Memento, you can actually take your state and externalize it to something like a database or a file.
Okay, well, that's fine.
Yes. So with Memento, not everything is in memory. It's all goes away when you close your application.
Okay.
And that brings us to what was being discussed here, where there is now mention of the serializer pattern. Because sometimes you can then use serializer to implement some sort of Memento, but then it doesn't become Memento the moment your state is being serialized to your database, because there's no way you can guarantee that these states will not be accessed by anything else but the original, because already once it's in a database, it's available for everyone. So the moment we introduce serializer when implementing a backup and restore facility, then it ceases to be actually Memento because of that. So that's why you see there was a mention of serializer here and a whole explanation around the difference between Memento and serializer, and where sometimes you can use both serializer and sort of Memento, because then your Memento class could be taking this state and storing it in a file somewhere, and then when you restore it, takes it from the file, recreates it, passes it back to the set Memento function. But then that won't be like Memento, because we are then violating these encapsulation requirements of Memento. But again, it shows that understanding is important because it allows you to answer questions when you start getting these serializer versus Memento type of questions.